Hello, this is 2.5. The topic is how to transform basic graphs. So, to begin this section, I am just going to tell you what a few basic graphs look like, and we will have to commit these graphs to memory. So the first graph we should know is y equals the square root of x. As the following graph. Starts at the point 0, 0 and has a shape like that. Okay. Y equals x squared. It sort of looks like a U. It's a shape we call a parabola. Okay. So this is y equals x squared. Y equals 1 over x. It's a graph like this. Okay. If I think of another graph, I will write it down, but I think that's about all we need to know for now. Oh, I'll give you one more. The absolute value of x has a graph that looks like a V. Okay. So here's 4 basic graphs. We will just have to memorize these shapes. And if you encounter another basic graph, say in the homework or something, and you don't know what it looks like, you could just search on the internet, the graph of this. It'll come up. Okay, so the topic of this lesson is, if we start with a basic graph, can we transform it into a more complicated graph? Right? That's the question we want to answer, and the answer is yes. So let's think about the transformations we could do. Say if we have this graph, one thing we could do is flip it upside down, or we could move it to the left, we could move it to the right, move it up, we could move it down, we could sort of stretch it vertically, shrink it vertically. Right, so those are things we could do. We could also flip it about the y-axis. Well, since this one is symmetric, it will look the same. We could flip this one about the y-axis. Okay, so that's all the things we can do. Let me write that down. Let's see. So for a function f of x, we have the following transformations. Okay, if you multiply a minus sign to the outside of the function, that flips it upside down. I'm going to do an example shortly of all demonstrating all of these transformations, but for now I just want to list them. If we multiply the minus sign to the input, so the minus sign is inside now, that flips the graph about the y-axis. Okay. If we input in x minus a, that shifts the graph to the right by a many units. Similarly, if we plug in x plus a, that shifts to the left by a. Okay, so minus sign here means we go to the right, plus sign left. Okay, then if we add a number outside of the function, so notice the difference between this and that. Here we're adding a number inside of the input. Here we're adding a number outside of the entire function, so notice the difference there. This shifts the graph up by a units. Okay, similarly, if we minus a, but on the outside, that will shift down by a. Okay, and the last thing we could do is multiply a number to the outside of the function. And then, well, there's two cases here. It's well, let's first just assume this number a is positive, because if it's negative, then we're kind of overlapping with this case here. So we already know what happens when a negative is out front. It flips upside down. So let's just take the two cases we have when a is still positive, but it's less than 1. That's one case. And then when a is greater than 1 is another case. So when a is a number smaller than 1, this will shrink vertically. When a is a number bigger than 1, we'll stretch the graph in the vertical direction. And again, I'm going to do an example to demonstrate all of these shortly. I just wanted to list them out. Last thing we can do is multiply a number. Multiply a number to the inside. Now this one is kind of counterintuitive, so maybe I'll just start with an example here. So say we have the graph f of x equals the square root of 3x. Okay. So what we can do is start with the basic graph that I told you we should memorize, and that's just the square root of x, which has a graph like this. Well, let's plug in some numbers to this. So to say we plug in the number 4, it's the square root of 4. Okay, that spits out 2. So we plug in a 4, it spits out 2. Now let's plug in a number to the f. Plug in 4. What do we get? The square root of 3 times 4. Square root of 12. Okay, so we plugged in the 4, get the 12 out. Sorry, square root of 12. So what happened between here and here? We sort of stretched it vertically, or equivalently, we kind of squished it in horizontally. Right. So let me clear some space to finish my list here. So here, if a is less than 1, a is greater than 1. So what we just found with that quick example was when a was greater than 1, that shrunk in the horizontal direction. And then in the other case, we have stretching horizontally. Okay, let's just look at a few examples now. So say we want to graph negative x plus 3 squared plus 2. So again, what we do is start with one of our basic graphs I gave at the beginning. Just the basic graph that looks similar to the graph we are given. So notice how we have something squared, which means we can start with this basic graph and make the necessary transformations to arrive at this graph. Right, so first we could just graph, this is the graph of x squared. Okay. Next, we can make a transformation. Let's look at the graph x plus 3 squared. Well, as I mentioned in my list, if we add something into the input, that will shift it to the left by, in this case, 3. So now we shift the graph to the left by 3. Okay, and we have the graph of x plus 3 squared. So almost there. We just need to deal with these transformations now. So the next transformation, let us, we could deal with the minus sign now. Now it doesn't really matter in what order you do these in, as long as you are careful. So then recall the minus sign flips upside down. So now we have this graph, right? We flipped the previous graph upside down. Okay, and lastly we can add a 2 to the outside. So this is being added on the outside, not to the input, so this will shift the previous graph up by 2 units. And there we have it. We have the graph of negative x plus 3 squared plus 2. When you look at this just at the beginning, it made it look complicated, but just starting with a basic graph, we only needed to make a couple transformations to arrive at the desired graph. We just shifted to the left 3, we flipped it upside down, and then we shifted up 2, and we arrived at the desired graph. Okay, now let's try another example when we kind of work backwards from the example we just did. So here, let us write an equation that has a graph with the shape of y equals square root of x, but it will be upside down, to the right by 4, and down by 3. Okay, so we have 3 transformations we want to do to this graph. And we're just going to do it algebraically, we're not going to graph it. We want to find the equation. Okay, well, let's just take it one by one. First, the upside down. Remember, the minus sign on the outside of the function makes it upside down. So that makes it upside down. Okay. Now if we deal with the to the right by 4, that means you minus 4 to the input, like this. That goes to the right by 4. Last transformation is down by 3. How we do that is we minus 3 to the outside of everything. Okay, and that is the equation for the desired graph that we were asked about. Okay, another type of problem you may encounter is you're just given an equation, say given y equals 4 times 1 over x minus 3, and you just need to list the transformations. Being done to the what we sometimes call the parent graph. So what is the parent graph? Well, the parent graph is one of these basic graphs I gave you at the beginning, sort of the starting point, so they call it the parent graph. Okay, so for a problem like this, clearly the parent graph in this case is 1 over x, right? And well, what do? We're stretching this vertically by 4. That's what this 4 is doing. Another thing is we shift down by 3. That's what this minus 3 on the outside is doing. Okay, so you may be given some equations and you just need to list the transformations, and you can find all of them through this list. Right, and then again, these are sort of your basic parent graphs that you may encounter. Okay, so once you memorize the shapes of these parent graphs and get a little bit of an intuition on these transformations, it's a pretty easy section. So I will end this lesson here. Thank you.